Today we have Andreea Munteanu from Canonical speaking with us, doing a workshop, very practical, hands-on workshop. I'm very excited for. I'll let her introduce her topic in much more detail because she'll know a lot better than me. Getting started with AI on AWS with MLFlow and Notebooks on Kubernetes. It's going to be really interesting, very practical, which I love. But for now, I will hand over to Andreea. Over to you.
Thank you, and hello, everyone. I'll have to confess, I'm a bit nervous. It's my first time with the DoKC community, but I'm excited to be here. I'll go ahead and share my screen. Meanwhile, I maybe start introducing Canonical. We are the company behind Ubuntu, the biggest Linux distribution, and I'm the AI product manager there. I've been working with Canonical for almost 4 years now. Today, I'll be talking about how to get started with AI on AWS with MLFlow and Notebooks on top of Kubernetes, as Hugh already said. Why AWS? Well, because it has all the compute power that you might need. MLFlow and Notebooks are easily accessible, and on top of K8s, because in Canonical, we do love cloud-native applications. So shortly, we'll talk a bit about AI, then AI on the public cloud, and then we will move towards an intro to MLFlow, and finally, a hands-on experience, which I hope it will be fun. At the end of it, I'll share all the links as well, so you can have fun even afterwards. Get started with AI. At the moment, I'm running a workshop, so I feel like I'm just repeating myself a lot, but I always say you should never start with AI just for the sake of it, but identify a use case. Don't do it because, I don't know, your best friend does it. Don't do it because you heard my talk and you thought it was fun. Just do it because, or begin with a use case that you believe. Otherwise, on one hand, you will not find return on investment on what you do, but then also you will easily get bored or frustrated. Back when I started initially, I found a use case that I deeply enjoyed. It was for Romanian language because I'm originally from Romania and there was no AI or no more or less text-to-speech for Romanian. And that's what I've built. And then after that, I ended up doing use cases and working only on use cases. Once you have the use case, look at your data. And I always say again, data is the heart of any AI project. If you don't have data, it's going to be difficult to build any project. But at the same time, you have to assess your data. How often is collected? How good it is? Do you have enough data volumes? Because otherwise, you might struggle and you might find it difficult, or you might find that your performances are not good. Then you'll move towards the stack. And I think that's where a lot of data scientists, I don't know, do we have a lot of data scientists in the room? I would love to hear that. So then a lot of data scientists love looking at the stack, but then they also get frustrated because of all the incompatibilities that go up there. And finally, you build your model. That's what we all love doing. We build models, we validate models, we play with parameters, we play with data sets, depending on what's the approach that you have, if it's model-centric or data-centric. And in the end, you deploy your model. Whereas this is, it feels like a flow that's linear. It's always a process that repeats and needs to be repeated because people's behavior changes over time as well as data does, and your model can easily become outdated. To get started with AI, you can and you should always start locally on an Ubuntu workstation. But I say this because I work at Ubuntu. Of course, you should start on the OS or on the environment that you like the most. Ensure that you have enough resources, and then as your project grows and you start having needs such as repeatability, reliability, you will start introducing different tools in your stack. MLFlow is one of them. It's, I think, one of the most popular tools, but we'll get to that. And then you can always scale with open source using Kubeflow, for example, and deploy AI at the edge with different tools as well, or frameworks such as Triton or Seldon. I did not mention something. I do have open source under my skin and in my heart. I'll be talking and I'll be using open source tools throughout this workshop and in general in Canonical. That's what we talk about. I think they are nice to help you get started without a big investment, and They're also nice in the long run because they give a lot of flexibility. Then, again, I think this is a bit obvious, but why it's important to run artificial intelligence? Well, I think it started initially with research, and that's something that we see heavily in the industry. But nowadays, it goes far beyond, from personalized experiences to process improvement, task automation, or cost savings. We all can easily find reasons why we should use our AI, and I don't think it's necessarily needed for me to go into details. But why AI on public cloud? That's maybe easier and more interesting to catch on. The truth is that public clouds are handy, they are accessible to everyone, and they are quite easy to use. So they give you an environment where it's easy to install things, and they support open source tools. In Canonical, we do have managed or services, but that's not that important. As important it is to the ease of maintenance, as well as the ability to get all the capabilities of an open source MLOps platform on an environment that can actually provide you the compute power that you need. And I'll move now towards MLFlow. Its journey started around 5 years ago with its first release. And I think what the community did great was to actually always run surveys. The first one was 6 months later, to understand the customer needs, user needs, in order to actually improve the product and make it a user-driven product. The first release comes in the same year, and I think another important milestone came when MLFlow integrated with PyTorch. From 2020 until now, it integrated with plenty of other tools, and it's quite nice to see how easy and how seamless it works with many of them. If I look at important milestones, I think the day or the month when they announced having 10 million users, it's important, because if we think of AI getting a lot of traction only in the last couple of years, when I was a student, AI was really considered a unicorn, whereas nowadays it's mandatory in universities, in engineering schools and computer science universities. I think there is a huge step, because the educational system understood that artificial intelligence and machine learning is here to stay. And then this number of users just confirms it. Last but not least, in September this year, Canonical released its own distribution, Charmed MLFlow. And with this, I'll go to the challenges that MLFlow solved. And the truth is that data scientists struggle with experiment tracking, with code reproducibility, but also with package standardization. There were way too many packages or methods to package, and that was frustrating, but also model management, because both we don't experiment once, but also we don't have only one model. And how do we manage and track these things was a challenge that data scientists had. So I do think that actually MLFlow came with some great capabilities or some great tests by giving the ability to professionals as well as enthusiasts to reproduce results, to have an easy way to get started. I remember I recorded a video a couple of days ago or a couple of weeks, and actually you can install MLFlow in less than 5 minutes. It took me 3 minutes. And it's worth mentioning that nowadays as a product manager, I don't have enough time to tinker with technology, so I feel I'm a bit slow. But then it is environment agnostic. You can deploy it directly on your machine, but you can also deploy it on K8s, the way that we'll do today. That's exciting, and I think that's interesting, because then it gives easy a way to migrate or to look in perspective on, why do I do this project? How do I think it will evolve over time? But also it works anywhere. Anywhere. If it's private or public cloud, it has no problem. So MLFlow is an open source MLOps platform that has plenty of capabilities, but the most important ones are that it can allow users to manage workflows as well as artifacts in a seamless manner. And I'll go towards the components of MLFlow. It has four core components. MLFlow tracking, it's used to record queries, to record and query experiments. For that, they have code. They look at the code, the data, but also the configurations and results. This is the component that actually allows reproducibility of results. And if we are being very honest, it gives us an easy and seamless path to look into how to get back to an experiment that we've done, I don't know, 3 days ago. MLFlow project, it's an add-on that was that appeared after as a need, and it packages data science code in the format that enables reproducibility, such that it can run on any platform, giving professionals flexibility to do it wherever they want. We have MLFlow models, which basically deploys ML models in diverse environment, and model registry, which really focuses on storing, managing models in a centralized repository. I think it's very interesting how MLFlow actually evolved over time, and I would strongly encourage you to look over it. But then we'll also play with it. We'll deploy it in a couple of minutes, and then we will chat about it. What's Charmed MLFlow, you might wonder? Well, Charmed MLFlow is Canonical's distribution of the tool. And to give more context, Canonical started as the company or the publisher of Ubuntu, but nowadays we have solutions across all layers of the stack. They're all open source. And we often get this question, what's the difference between the upstream projects since they're both open source? Well, we offer integrations with other tools such as Kubeflow, which is a great MLOps platform to run AI at scale, or with Spark, which is great for data streaming. But we also have observability capabilities. We offer timely bug fixes, ensure security patching. And then from an organization perspective, we offer enterprise support or managed services. And here we are, it's demo time. But before we get into that, maybe I'll take a look at what we will be using. Here I have some examples of hardware that we often run AI workloads on. We will be using an AWS instance this time that has Ubuntu on it. On top of it, it's going to have K8s, which is Canonical's distribution of Kubernetes. It's a low ops, super easy to install Kubernetes distribution. I'm happy to share the link in the chat at the end, but we'll also deploy it. And then on top of it, we'll have MLFlow with Jupyter Notebook as the main. I still believe that they are the tools that data scientists and machine learning engineers prefer, but of course I'm biased. It's worth mentioning that. And also Juju, which is a lifecycle management tool. Cool. So I'm SSHing into my EC2 instance. I think it's quite a basic activity. I use the public IP, and now I'll go directly to installing or to setting up my environment. The very first step will be to install K8s. And I think what's very special about this workshop is that I can do it live with you. I hope it doesn't crash, because then I will look very bad. But it's quick enough and it's seamless enough that you can do it in a 1-hour workshop, and I expect it to take shorter. So as I mentioned, we are installing K8s. I'm installing 1.24, but newer versions are available as well. It's packaged into a snap at the moment. If you're not familiar with it, you can check it out as well. And with this occasion, I can also share the very first link, which is the guide to deploy it. Meanwhile, it's installed, so I'll go to the next step, which basically makes I'm making K8s to run without the sudo part. Always, it's more convenient for my activities. Nothing too fancy. I'm going to next command to have access and ownership to the kubectl commands, and then I'll configure my cluster and the necessary service to run on top of it. Also, I'm promised to share more details with you about K8s. Oh, not here. Okay. But in the chat. And since I heard people are not necessarily familiar with MLFlow, maybe, is it supported on Minikube? Yes, it is. So yes, it is. That's a good question. Charmed MLFlow is supported on any CNCF conformant Kubernetes. And also maybe I will add something here while we are waiting or we are showing that it runs that except for the fact that it's supported, since we are open source, you can always post or ask us anything on our Mattermost channel or on Discourse, such that they actually stay, and we will happily answer. I'll move towards installing Juju, which is, as I mentioned, an operational lifecycle manager for clouds, bare metal, and K8s. Or you can also ask us on Data on Kubernetes Slack channel. If you tag me, I'm there. I find it very impressive because now I'll share random thoughts while it installs. But when I started looking into AI and data science and all these things, there was no community to make you feel supported. And it really felt a bit of a wild fight, which is quite nice now that it's all nice and organized. And I don't think we genuinely or easily do that or recognize that. Now I'll bootstrap, I'll deploy a Juju controller and set it up with with micro-K8s. And my next step will be to add a model to the controller once this installs. So we might have to wait for a bit. Okay, looks like it worked in the end. Okay, so we deployed MLFlow. Meanwhile, as you see, it took us 5 minutes. Then we will have to install Jupyter Lab on the same instance. I think I'll have to update. Bear with me. Meanwhile, I can also share this part of the guide with everyone in the audience. Also, I have to maybe share some fun projects that I've done in the past. One thing that I loved doing as a student was to predict my costs. So I used to build predictive analytics based on my costs on how would I spend my money on. And that was life-changing to me. It would help me understand better and also turn into a more, I think, financially responsible person. And it was just for my use case, my own benefit, I'll have to say. Also, recently, I've heard a very nice story from someone from Thailand, actually, that used predictive analytics for a crayfish farm. So they had cameras above their buckets, and the gentleman built a model that would automatically detect if the shells of the crayfish would go down, because if they're not taken out, crayfish dies. And he built a model. It would automatically alert the owners if that happens. And it was quite a life-changing experience that grew the chances of crayfish to actually live longer. And these are just fun projects that I can think of. We will have more at Ubuntu Summit. We have an AML track only with this kind of projects, which is very exciting. Okay, so we also installed Jupyter Lab while I was sharing random stories or random use cases. It's a simple command, pip install Jupyter Lab. Now we'll have to SSH once again to include all the necessary paths. So I'll open a new tab. I'll go to the right folder where my K pair is. And let me copy again my public URL. Because that's an older one. I've done some tests before. .64. Cool. Let's see. Yes, it worked. Also, I think one thing that we should be doing, 1 second, is to get our repository of models, of examples, because I'll take one example from their initial, I'll have two examples, but I'll anyway clone my repository of examples. As anything else that I shared so far, it's open source. It's available to everyone, not open source. You can play with it, contribute to it, have fun with it. Our engineering team maintains it. I'm not saying that everything that you will find here actually works. There are things that work, there are things that might fail, but also if you run into a problem and you solve it, we would really appreciate if you contribute back to it. They're just examples. Some of them are easier, some of them are not that easy. Okay, let's start Jupyter Lab. And now it's the big challenge. Does it work or it doesn't work? Let's see. That's my old instance. Let me take the URL. For those who are not familiar, I basically started Jupyter Lab and I took my the URL with the token to be able to access it. Maybe not. So 1 second. Let me bear with me 1 moment. Let me check a couple of things. The first thing would be to ensure that actually my proxy settings are okay. That's not what I hoped for, but they are. I have manually set the proxy. There's no reason for me not to. I think that happens like this always. You do it before, it works fine. Do it once again, something breaks. Let's see. I'm trying to SSH again. Let me see. No, everything seems active and seems working. Let's try again. Basically, to access Jupyter Lab, I use a Firefox browser. I will mention again, I realized I showed it, but it didn't, I was not showing the right window. I think it happens always in meetings. In order to do that, or to use Firefox, I use the proxy. I set it on manual proxy configuration, and then I change the host and the port. And then here we have two projects. Actually, 3 of them. This one is a very basic one. I'll run it and then I'll show you. And then there is a more advanced one. Also, we have one that runs with Kubeflow because we integrate very well with Kubeflow. Also, we can access the UI of MLFlow. We have also some of my older tests. And then we run it. I wish everything was smooth. Okay, here we set the environment variables. In order to do that, maybe let me reshare my terminal for 1 second. There we go. Okay, I'm going to a new tab, making it bigger again. So in order to see the environment variables, there are 2 types. First, you will need to access and configure min.io, which is our storage object solution. For that, I think in both of the guides that I shared with you, you will see the necessary commands. There we go. So you see here the access key and secret access. keep them in mind for a second because I cannot share two windows at the same time, but you will see that I update them in the Jupyter notebook. The other two ones are that I need are the Munteanu, the S3 endpoint, and then the MLFlow, tracking, which is basically the MLFlow tracking server URL. In order to do that or to run that, I will run a kubectl command, which is usually this one. There we go. And then we have here the IP and the port. That's what I will use. I'll move towards the other part just also for the sake of time. I realized I said, oh, it won't take long, but here I am. Anyway, so as you maybe remember the access key, I set it to Munteanu, the secret access. It's the one that I shared. Of course, I suggest usually when you run in production, don't share your keys the way that I just do now. Do it in a secure manner and ensure that they are securely stored. For the sake of time, I won't go through that now. And then I'm using a very basic example that uses a scalar and then a random forced regressor. Let's see, I run it. I have a warning. I'm using some outdated. Let's see. Why is it? I do have two warnings, but then if you look here, I just see my experiment. You can go to it. You can see plenty of things about it. You can see the input, you can see the output. You can see all the parameters that have been set. For example, max depth 6, max features 3. And if we go here, we can always readjust them. I modified one just to show you this. And whenever we go back here, you can actually refresh. There we go. And you will see that one of the parameters changed. You could also play around here. You could see the performance of it. You could compare performances as well. You have the models part, which is used for model management as well, which is important when you start building more than one model. And except for that, here you can see what model what you used, was the source, how long ago was created, as well as how long it takes. You might say that this is not important, and this is not important when we have basic examples like this one, but this becomes crucial, I'll have to say, once you start having more complex projects, because you will not only have to optimize on model performance or experiment performance, but also you have to optimize on how long it takes, because you don't want to train for too long on one hand, but also you don't want to waste all the resources when on the other hand, because at the moment, the truth is that compute resources are quite scarce. I will stop here. There are plenty of other use examples. We have more of a complex one. Again, we go to the environment variables. Let me actually run them. We print them to ensure that we didn't do anything wrong. We install necessary libraries. We import everything that we need. We use data about wine. I almost wonder if my colleague who built it was not French, or who knows, since we end up having a wine example. But then we run it. This one is nicer because it has all the details as well and all the comments, so you understand what's happening. It also tells us that, hey, there is another version of it. And then here you are. You also see that here, in case you have an experiment that's not visible, it tells you that you should refresh. You also have the ability to add plenty of other things depending on what's important for you. Plenty of other columns in the default visualization, I do think that the UI is fairly intuitive. You can have more than one experiment, as you can see here. I created 2 of them for my own fun. That would be pretty much it on my side. The other examples are available there. I will go back to one more thing. I'll take 1 more minute and then I'm done, actually. I mean, not done. I'm happy to get questions. There we go. When it comes to demo time, so this is what we showed, or what I showed you on the screen, but then how would you scale it? Well, by integrating new tools, and here I have Kubeflow as an example, because it can not only show, that does not only do experiment tracking by integrating with MLFlow, but also it can automate pipelines. But then you can also use data fabric solutions. I mean, I have here Canonical data fabric, but you could use in general tools such as OpenSearch or MongoDB, depending on your use case. For example, if you need a vector database, OpenSearch is ideal. If you want to do data streaming, you will have to look at Spark as well. You can always consider integrated with the open source NGC containers as well. And then you will also, or you might also want to look further than just GPUs, having DGXs or EGXs in case you, I don't know, have a huge project or you work as part of an enterprise. And that was it on my side.
Thanks so much, Andreea. That was fantastic. I always like practical workshop where you show you doing stuff instead of just talking about it. And that was great. So thank you so much. Yeah, I really enjoyed that. And see you on Slack. Thanks very much, everyone.